All right, friends, we have section 4.3, letter E, and this problem is called river crossing. And the problem is you're on one side of a half-mile wide river, and you wish to cross, then travel 3 miles to point B. Now, this is you, and I didn't say that your boat, but yes, you have a boat to start out. What is the optimal spot to cross to so that your trip is fastest? And so the thing is that I could go here and I could go straight across the river. I could go all the way to point B, or I can pick some unknown spot here, row to that point, and then walk the rest of the way. Now, I want my trip to be fastest, but we're told that we boat at 1.5 miles per hour and we walk at 2 miles per hour. So, we have our picture, but what I haven't included is I haven't included a variable, and some of you are seeing where that variable goes, and it's going to be right here. X is going to be the distance directly across the river that I boat to. X could be 0, then I boat right across and then walk the 3 miles. X could be 3 miles, and then I would boat the entire way. But so if that's the case, if we have X right there, then really the picture looks something like this. Half-mile wide river. X is right there, but this is the path that we boat. And now here is the path that we walk. We can see that this path, the whole distance across the river to point B was 3, and so that distance is 3 minus X. Okay, so we've taken our picture, we've made a better diagram, and now let's start to use formulas. And we should probably say that this is going to be a right angle there, and so we can use the Pythagorean theorem. And that distance is 0.5 squared plus x squared. We take the square root, yeah? That's the distance for the path of the boat to travel. But we don't really want the distance. We want how fast it's going to take us. And we can remember that distance is equal to rate times time. And so if I want the time, I can divide by the rate. And so my time will equal that value divided by the rate, which is 1.5 miles per hour. But we're not done. We're not done. Once we get across to that point, we're going to be walking the rest of the way. And so we're going to have 3 minus x, that's the number of miles that we're going to be walking, and we'll divide that by 2. All right, so here's our relationship. We have only one variable to contend with, and so we can take the derivative and begin to find our critical points. Yeah. So dt dx will be equal to, and I'm just going to write 1 over 1.5, and then let's just say 0.5 squared plus x squared to the negative 0.5 times 2x, making sure that we do the chain rule there, and then plus 0.5, so I'm just taking the half, and then the derivative of this is negative 1. Okay, we'll set it equal to 0, and we'll begin to solve. So 0, and in fact, I'm going to bring this right to the other side because it's going to be so we'll have 0.5 over 1.5. I'm going to put a 2x upstairs, and I'm going to put all this gobbledygook, 0.5 squared plus x squared to the 0.5 downstairs, minus 0.5. Now, we can see a couple moves that I can make here. I'm going to bring the 0.5 to the other side of the equation. I'm going to cross multiply, so bring all of this trash up here. So I'm going to have 0.5 times 1.5 times this whole denominator term, 0.5 squared plus x squared to the 0.5, and that'll be equal to 0.5 times 2x. Now I got a half over here, I got a half over there. I can murder those two out. And then what I want to do is I'm going to divide by 1.5, and then I'm going to square both sides to get rid of that term, raising to the half power. So let's do 0.5 squared plus x squared is equal to 2x over 1.5. And remember, that whole thing was raised to the half power, and so I had to square both sides to get rid of that. Yeah? And let's just see what this is going to resolve itself as. 2 divided by 1.5, and I can square that beast, and I'm going to fraculate it. So it looks like I get 16/9. So I have 1/4, which is a half squared, plus x squared is equal to 16/9 x squared. Let's subtract x squared, and let's get rid of the constant. So we'll have 1/4 is equal to, and we'll have 16 minus 9, so 7/9 x squared. Just bringing that 9 over 9 over. And then we'll multiply by the reciprocal, so we'll have 9 over 28 equals x squared. And we have two solutions now. It looks like we're going to have plus or minus, and yeah, we'll just go 9 over 28 equals x. Now, of these two solutions, only one is a legit solution because we need positive values. So our critical point is root 9 over 28 miles. And so that's where we should cross to. I'm just going to enter that into my calculator so I know. Square root 9 over 28. And this is around 0.567 miles. We're not done. We're not done. We have one last thing to do, and that's to test. So in order to test, we need to think about the domain, and the domain is x. What's the smallest x could be? X could certainly be 0, yes? And the biggest it could be would be 3. And so if I go back to my original setup right here, I'm going to look at t when x is 0. And when x is 0, we're going to have 1.5 right there. When x is 0 here, we're going to have a half squared, but the square root, so it's just going to be 0.5 over 1.5 plus 1.5. And that gives us a joyous, how many miles per hour? 1.83. And that's not miles per hour. I'm sorry, that's just hours, yeah? We're going to take t and we're going to evaluate it at our critical point. And what I'll do here is, once again, I'll just enter in the square root of 9 over 28. And I'm going to store that as a. And so when I go to my formula here, I can have the square root of 0.5 squared plus a squared. I'm going to bang that, divide it by 1.5. I have 0.503 for this term. And then I'm going to add to that 3 minus a divided by 2. And I get 1.72 hours. Our final thing that we have to look at is we have to evaluate our function at our final endpoint, x equals 3. And what I love about this is that that whole term is going to murder out. When x is 3, we just boat the entire path. And so we're looking at the hypotenuse of our largest triangle. And so we'll have the square root of 0.5 squared plus 3 squared over 1.5. And I'll bang it in here. 0.5 squared plus 9 divided by 1.5, and we get 2.03 hours. These are all decimal approximations. We've tested our two endpoints and our critical point, and it turns out our critical point is the fastest. We found the fastest place to cross to. So The moral of the story is, if you're boating, make sure that you bring a calculator with you so that you can figure out the optimal place to cross to.